here, reporting live here at the River School with breaking news. There has recently been an outbreak of violence at the normally tranquil River School. We have footage of these alleged incidents and the damage that they have caused. We will then sit down with a correspondent from the PNN, the Physics News Network, to explain why these events caused so much damage. Welcome back. I'm just doing some light reading. Maddie here with the Physics News Network back at the River School to report on why all the teachers are punching the students and all the students are punching the teachers. We're going to sit down with one of the victims, Lindsay Burrows, to talk about these strange occurrences. Welcome to the show, Lindsay.
Thank you for having me.
So how does it feel to be victimized by your own teachers?
It's very painful. It really hurts my self-esteem.
I can imagine.
Teachers.
So do you have any reason why when you rode with the punch, it hurt less, but when you didn't ride with the punch, it really hurt a lot?
I'm not really sure. I think it's because of impulse and momentum. Impulse
and momentum. Right you are. Now let's talk about why this is so. To ask the question, how does the change in momentum and time affect the force of the impact? Well, the greater the impulse acting on something, the greater the resulting momentum will be. This can be described through the equation force times time, which is impulse, equals change in momentum, which is mass times volume. We will address how impulse is related to increasing momentum, decreasing momentum over a long time, and decreasing momentum over a short time. To increase the momentum of an object, the greatest force possible must be applied for as long as possible. To decrease the momentum over a long time, the time during which the momentum is brought to zero must be extended. A longer period of time would reduce the force. Similarly, to decrease momentum over a short time, the force must be smaller and the time period must be larger. Now let's take a look at these principles in the context of the fights going around school. Since force times time equals change in momentum, by extending the time of the punch, you are making the T bigger, thus making the force smaller. This makes the punch hurt less. In this next scenario, as Dan does not ride with the punch, the time is made smaller, so the force is greater. As a result, the punch hurts more. The impulse is the same in both scenarios because no matter how the punch is stopped, the impulse is the same. This principle can also be applied to a car crash. If the car were to be driven into a haystack or a wall, the same impulse would be needed to decrease your momentum to zero. When a car is run into the wall, the change of momentum occurs over a short time so that the hitting force is large. This causes the car to crumple. By hitting the haystack instead of the wall, you extend the time during which your momentum is brought to zero. Thank you for tuning in to the PNN, the Physics News Network for Fox Fox News as we use today's breaking news to explain the relationship between impulse and momentum. We'll see you tomorrow night.
All we need is a little bit of momentum. Break down these walls that we built around ourselves. All we need is a little bit of inertia. Break down and tell that you are the rain on the fire, deep in the trees.